We are going to review special right triangles and trig ratios today. We're going to start by a quick review of the simplifying radicals when you have a denominator that has a radical. So to simplify a radical, what we do is we take the denominator, which is a radical, and multiply both the numerator and denominator by that radical. When you do that, the top becomes 5 square root of 2 in this example, and the bottom, the denominator, is square root of 2 times the square root of 2, which equals 2. So for the first problem down below here, we're going to multiply this by square root of 2 over square root of 2, and then our numerator is now 6 square root of 2 over 2, and when we reduce that, it becomes 3 root 2. Okay. The second one, you're going to multiply by square root of 3 over square root of 3, and when you do that, the numerator becomes 4 root 3, and the denominator is just 3. You can't reduce that because 4 is not divisible by 3, nor do they have a common factor other than 1, so that one is finished. And then the third one, and this one is going to come up a lot in the coming week, the numbers 3 and 4. So this is why I do these now, to get you to look at these two problems early in the unit. So the first, the numerator is going to be 2 square root of 2, and the denominator is going to be 2. Notice 2 divided by 2 is 1, so this is just going to equal square root of 2. And the last one, my denominator is square root of 3, so I multiply by square root of 3 over square root of 3. And I don't need the 1 on top, so I can just write square root of 3, and the denominator, square root of 3 times square root of 3, is just 3. So there's your warm-up. Next, we're going to do a quick trig review. We're not going to do everything on the notes that I gave you. We're going to do just a quick review of what the trig functions are, the trig ratios are. So sine, we pronounce it sine. We abbreviate like this. It's not sin, it's sine. We say sine. And we use its opposite over hypotenuse. So if your triangle had an angle theta here at angle A, the hypotenuse would be the side opposite your right angle. The opposite leg is a leg opposite your theta, which would be A. And then the adjacent leg, the leg that's touching your angle, is B. One thing I tell my students, put your thumb on the actual angle. Whichever leg your thumb is touching is adjacent. Adjacent means next to or touching. So opposite over hypotenuse in this would be A over B. Cosine is adjacent over hypotenuse. So in this problem, we abbreviate it COS, but we say cosine. And it would be this would be A over C. I'll bet you guys caught that. A over C. And this one would be B over C, because hypotenuse is C. This one, tangent, abbreviated TAN, but we say tangent, is opposite over adjacent, so that would be A over B. And sometimes we use the abbreviation SOH, S-O-H, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over hypotenuse, to help us with these problems. So to use the ratios you just learned, what are sine, cosine, and tangent ratios for angle T? The sine, okay, so angle T is my theta. So that means, well, we always start with our hypotenuse because that's opposite your right angle. Adjacent is the one touching T, the leg touching T, so that would be ADJ goes here. This will be my OPP, or opposite. So if I need the sine of T, that equals opposite over hypotenuse, so that would be 8 over 17. Cosine of T would be adjacent over hypotenuse, and that would be 15 over 17. And tangent of T is opposite over adjacent, so that's going to be 8 over 15. Now, if angle G were your theta, then hypotenuse would stay the same, but adjacent and opposite would flip roles. Okay, so how do I use that in a problem? Well, let's say I have, this is my theta. So first you label your sides. So your hypotenuse is always the side opposite the right angle. Adjacent is the leg touching my theta, so that would be this one. I don't really need that one in this problem because this is the one that has something on it. So thinking about SOHCAHTOA, if I have opposite and hypotenuse, I have O and H. That means I'm using sine. So I do sine of 54 equals W over 17. Now to get W by itself, you'd have to multiply by 17. So W is going to equal 17 sine 54. I'm not going any further in this unit with this because we aren't going to need to know how to put this in the calculator or anything for the unit that we're teaching right now. Okay, so B, if this is my theta, the two sides I have are my legs. The one touching theta is adjacent. The one not is opposite. So if I have opposite and adjacent, that means I'm using tangent. So I have tangent of 28 is equal to 1.0 over W. Now whenever the ratio has your variable on the bottom, just switch these two spots. So you'd have W equals 1.0 over tangent of 28. And if you needed to know W, it would be a decimal answer. You'd put that in your calculator. And that's where we're going to stop, because really all I wanted to get you to do is just to see this again, because we're going to be using sine, cosine, and tangent. Okay, the second part of today's lesson has to do with special right triangles. And this is the key part of the lesson today, and what your work that your assignment is going to go with. So we have two types of special right triangles. We have our 45, 45, 90 right triangle. We also have our 30, 60, 90. The first one is our 45, 45, 90. Both of these special right triangles have certain ratios in their legs related to the hypotenuse that hold for any of these. No matter what the length of your legs are, these ratios hold for any of these types of, as long as the angles are the same, 45, 45, 90, the ratios hold for no matter how long the legs are or how big the hypotenuse is. So I'm going to change these S's to P's because my P's my S's always turn out looking like 5s, and that's confusing to my students. So in a 45, 45, 90, the legs are both the same length. So we mark those with P. And the hypotenuse is P, or the leg, times the square root of 2. Leg times the square root of 2. So since the leg, we're using the variable P, it would be P square root of 2. So how do I use that? Well, first, label your triangle with the formulas. Okay, those formulas that we just saw in the triangle on the previous page. Set the known side, the side that has a number on it, equal to the formula, and solve for P. So basically step 2 you do all at once. Okay, step 2 and 3 you do all at once. Then once you know P, plug it in and simplify if you need to. That was what we did for the warm-up. So simplest radical form, rationalize your denominator. So in this right triangle, the legs make up my right angle, so this is a leg and this is a leg, so those are both P. The sides you have something on right equal to whatever the formula is. In this case, that's P, and this is P square root of 2. The angles are just there to show us what kind of triangle it is. So you don't have to use sine, cosine, or tangent for this. We're using these ratios that I just showed you. So which side do I know in this one? If you want to stop the video and then think about it and then turn it back on, it's back on, and now we know P equals 9. That's the side I know. So I take that, step 4, and plug it in. So if P is 9, I'm going to put a 9 there. So I have H equals 9 root 2. That's all you had to solve in that triangle. So that was a simple one. They're not always that simple. In this case, it was. Okay, the second one is the hypotenuse is P root 2, and the leg is P. So I know P is equal to 2 root 2. So I'm plugging that in for P. So I have x equals 2 root 2 times square root of 2. Well, square root of 2 times the square root of 2 is 2, so I have 2 times 2, or 4. So x equals 4. we are going to skip to, oh wait, I needed to go back to this one. Okay, so to find the value of x, if I know the hypotenuse in these triangles, then that's where our warm-up comes in. So again, this is a leg, so it's p. Hypotenuse is p root 2. So I have to solve using this equation right here. So 6 equals p root 2. Divide both sides by square root of 2 because I need to get the p by itself. So now I have p equals 6 over root 2. We did that for the warm-up. So I multiply by square root of 2 over square root of 2. And I have 6 root 2 on top and 2 on the bottom, and that reduces to 3 root 2. So now I have p equals 3 root 2, so that means x, which equals p, is 3 root 2. So once you get used to doing these steps right here, it's not gonna be a long problem, because a lot of times you'll end up just being able to do it in your head or real quickly. So, and you're gonna be doing a lot this week, so you'll get it. It'll come even if it's not right away coming to you. Okay, so we're gonna skip this and go to some practice problems. I'm gonna have you do 7, 10, and 11. So for 7, I have a leg, and a hypotenuse. So according to this leg, p is 8. So what is x? X is p, which is 8. And this one would be 8 root 2 because I plug in the 8 there. You should have turned the video off. Sorry. Turn the video off and then do number 9, 10, and 11. That way you're at least getting some practice in. So you watched me do that one. Now turn the video off, practice 9, 10, 11, then come back. So copy them down first. So now that you're back, number 9 is p, and this leg is p, and p root 2. So if this is p root 2 and this is p, I can just plug that 60 in. So y is going to be 60 root 2. Okay, so that's 9. 10, these are both p, and this is going to be p square root of 2. So I need to get p by itself, so I divide by square root of 2. And those cancel out, and I end up with p equals 15. So x and y are both 15, because x and y are both equal to p. And number 11. So this is hypotenuse, so it's p root 2. This is a leg, so it's p. So now I have to solve, just like that last example we did earlier, for p. Divide by square root of 2. And I have p equals 10 divided by square root of 2. And when you simplify that, rationalize the denominator, you should get 5 square root of 2. So that means x equals 5 square root of 2. Okay, so now that's 45, 45, 90 triangles. Now here's our 30, 60, 90 right triangles. So again, I'm going to change these s's to p's. And in a 30, 60, 90, you don't have, the legs are not the same. So the shorter leg and the longer, we have shorter leg and longer leg in this. So shorter leg is p, longer leg is p root 3 hypotenuse. So we have short leg, long leg, hypotenuse. P root 3 for the longer leg, 2p for hypotenuse. Okay, so in a 30, 60, 90, we have 3 different ratios. It's easiest if you find the hypotenuse first. So my hypotenuse is f, and that's 2p. Now I just have to figure out which is the shorter leg and which is the longer leg. If you're in doubt, look for your 30-degree angle, because the side opposite that is your shorter leg. So that's p, which leaves this to be p root 3. So what side do I know? I know the longer leg. So I have 5 equals p root 3. Divide by square root of 3. So I have p equals 5 over root 3. When I rationalize that, you get 5 square root of 3 over 3. Now, I know p, so that gives me d. So d is 5 root 3 over 3. But how do I get 2p? How do I multiply this thing by 2? Well, you just multiply 2 times 5 root 3 over 3. Well, this would be like 2 over 1. Multiply the coefficients, so that would be 10 root 3 over 3. So that would be f. So D and F. Okay, that one takes up a lot of space in your notes, I know. Okay, so the second one, this is your, always start with your hypotenuse, so that's 2p. Short leg next, p, and then p root 3. So this one's a nice one because the hypotenuse is just divide by 2. If you know the hypotenuse, you're just going to divide it by 2. And so divide by 2, and p is 3. So x is just whatever p is, so x is 3. So that was an easy one. Okay, so the last one we're going to do, we took an equilateral triangle and cut it in half. So now this top angle is a 60-degree angle divided in half, so this is 30, which makes this a 30, 60, 90 right triangle. So the hypotenuse is 2p. I don't need the shorter leg, which would be p. I need the longer leg. That's going to be p root 3. So I need to solve for that longer leg. So if I can get p, all I need to do is plug it in. Well, p is going to be 6 because it's half of 12. So x is going to be 6 root 3. And then we have a couple practice problems. I'm going to have you do 15, 17, and 19. So number 15, I have the hypotenuse, so I have 2p, short leg, long leg. So if p is 40, or 2p is 40, p has to be 20. So that means x equals 20, y is going to be 20 root 3. 17, I've got a 30, 60, 90. Hypotenuse is 2p, p root 3. So if 2p is 10, p has to be 5. So x is 5, and this is going to be 5 root 3. 19, now this is not the hypotenuse, this is the longer leg. Hypotenuse, remember, is 2p, short leg is p, and this is p root 3. Okay, so these square root of 3's, if I divide by square root of 3, those are going to go away, and I have p equals 2. So x is going to be 2 times 2, which is 4, and y is going to be 2. So that's the end of the notes. Now you need to do the scavenger hunt that's at the bottom of the or is included on my wiki page.